Let's proceed to the next question. Here we are going to find the asymptotes. So given a certain function here, so we're supposed to find the horizontal, vertical, and oblique asymptotes based on limit approach. So I'm going to show you how you can find all these asymptotes. So before we directly jump into the asymptotes, first let's see how we can rewrite this expression. Look, the given one is square root of 2x squared plus 1 over 3x minus 1. So let you take x squared as a common out for the radical expression in the numerator. So you are left with the 2 plus 1 over x squared. So we know that the radical of x squared is absolute value of x, as you see, and the square root of 2 plus 1 over x squared is left. And here I took x as a common out, and then 3 minus 1 over x is going to come. So look, this expression now can be written in terms of this form. I intentionally wrote in terms of this form because later this expression will help me to find the horizontal, the vertical, and the oblique asymptotes, as I said earlier. So what comes next is let's try to find the horizontal asymptote first. So this basically is obtained just looking for the limit as x goes to infinity. So as you look for the limit of the function as x going to infinity, you do have, you see, the function as it is written, but it has been simplified already. This is going to be like this. But as x goes to positive infinity, what comes next is the case where absolute value is going to be defined for large positive infinity. In the case of this, absolute value of x is positive, as you know. So we can cancel x by x, and then we are left with the square root of 2 plus 1 over x squared divided by 3 minus 1 over x. So as can be shown here, as x goes to infinity, 1 over x gets closer to 0, and that 1 over x squared, approaches to 0 at a faster rate compared to 1 over x. Hence, we can have this being simplified like this form. So clearly, you can understand that this is going to be the limit as x going to infinity of the square root of 2 plus 1 over x squared divided by 3 minus 1 over x, and this limit. So you are now having radical 2 over 3. The reason is because as x goes to infinity, you see the numerator approaches to radical 2, and the denominator gets closer to 3, so radical 2 over 3 is one asymptote, and proceeding to the other, we have another asymptote, and that is as x proceeding to minus infinity. So as x goes to minus infinity, again do the same, and as you see here, we are having radical x, and absolute value of x. So as x goes to minus infinity, this turns to be negative x, so negative x divided by x makes minus 1. That's why we are having here minus, then the square root of 2 plus 1 over x squared divided by 3 minus 1 over x can come. So as x goes to infinity, this gets closer to 0, and radical 2 is going to come, and here again this gets closer to 0, so 3 minus 0 is 3, so negative radical 2 over 3 can come. So basically here we do have two asymptotes, so horizontal asymptotes I mean. So as you are moving away from the y-axis, one is the graph gets closer to radical 2 over 3, and in the other direction our graph approaches to y equals minus radical 2 over 3. So these two are our horizontal asymptotes. So proceeding to vertical asymptotes, first we have to look for the case where, you see, the limit of this is going to be either positive or negative infinity. And that is obtained when you take, when you get closer to 1 over 3, because clearly the value that makes this undefined is 1 over 3, as you see. So let's get closer to this 1 over 3, either from the right or from the left. It is enough to really show either positive infinity or minus infinity, as we are getting closer to one side of this 1 over 3. So clearly, as you see here, as I'm getting closer to 1 over 3 from the right side, this goes to infinity. The reason behind this is because, as you know, the numerator is always positive. Whatever value you may take in place of x is always positive, and as you are taking 1 over 3 from the right side, 3 times a small number close to 1 over 3 but greater than 1 over 3 is going to be a number greater than 1, and that one minus that number minus 1 makes positive, because 3 times x is greater than 1. Even if it is a number close to 1, it's greater than 1, so that minus 1 makes positive. So positive divided by positive is positive infinity, positive actually, but since the denominator is a very small number, this is going to positive infinity. Okay, so we obtained one option. Here you are free to have either positive or negative infinity, one of these two. Now we are lucky enough that we got positive infinity, so this by itself is enough to say that x equals 1 over 3 is the vertical asymptote. So when we sketch the graph, you see the graph of the function never crosses, even touches these asymptotes. Mind you, student, that there are cases where you see our graph may cross the horizontal asymptote, because the idea is not to worry about whether it intersects or intercepts. That's not our intention. In the case of horizontal asymptote, to what line do you take the function gets closer to as x is far away from the y-axis, okay, as x goes to either positive infinity or minus infinity. But in the case of vertical asymptote, it is highly related with domain, so there will never be a means of the function to cross this asymptote, the vertical asymptote I mean. So now comes oblique asymptote. So in the case of oblique asymptote, students, we have to observe the degree of the numerator and the degree of the denominator. So for oblique asymptote to exist, you see this is an asymptote basically. It is an inclined line, a straight line. So for this to come, we must have a certain linear function expression, and that is attained when the degree of the numerator exceeds the degree of the denominator by 1. But in the case of this, it's not like that, because as you see here, you see this is something radical x squared, some sort which is close to x, and again this is again I mean, when I say close to x, I mean it is close to degree 1, and again this is degree 1, so you will never see this oblique asymptote. Hence we don't have this oblique asymptote for this particular case. I hope you have understood everything about these asymptotes concerning two limit approach. Here I just have brought one question for you. As usual, you are asked to find the horizontal asymptote for this particular function. Do the same as I did above and try to write the answer in the comment section, and don't forget to like, subscribe and share the channel. Proceeding to the next one, we have question number 19, and that is about, again, finding horizontal, vertical and oblique asymptotes, but in a different approach. Here the function is 2x cubed minus 3x squared over x squared plus 1. Clearly, student, here you can understand that there is an oblique asymptote because the degree of the numerator is 3, whereas the degree of the denominator is 2. As you see, the degree of this is 3, whereas the numerator is 3, or the degree of the denominator is 2. So the degree of the numerator exceeds or is greater than the degree of the denominator by 1. Hence, you expect oblique asymptote. And that is an inclined line, students. Y is equal to ax plus b. So here your a is obtained by looking for the limit of f of x over x as x goes to infinity. And the constant b is obtained by looking for the limit of f of x minus x as x goes to infinity, where your a is the one obtained here. So now let's try to calculate these values. So first let's calculate a. As I said, a is the limit of f of x over x as x goes to infinity. You are given that the function is this, so you copy this and paste here. And this has to be divided by x. So students, look, this is the same as multiplying x squared plus 1 by x. It is here, it is already multiplied, x cubed plus x. So the degrees are the same. Look here, students, so we can take the leading coefficient ratio, and that is 2 divided by 1 is 2. So as you see, 2 divided by 1 is 2, so the limit of this is 2, so your a value can be 2. Your a value can be 2. Proceeding to b, look, this is the same as the limit of f of x minus x as x going to infinity. As I told you earlier, your a is already obtained, so a is 2. As you see, a is 2, so you just simply put that here in place of a, and your function f of x is already taken, as you see. So directly substitute that over here, and then what follows is the limit of 2x cubed minus 3x squared over x squared plus 1 minus 2x. So we need to have further simplification for this. So as you are simplifying this, what comes next is this expression as can be shown. You can simplify this, very simple. Now if you try to observe again as you did before, the degree of the numerator is 3 with the leading coefficient minus 3. For the denominator, the leading coefficient is 1 with degree 3, so we can take ratio between these two, minus 3 divided by 1. So this limit is automatically minus 3. Even you can multiple both the numerator and the denominator by 1 over x cubed if you want. So finally you will obtain that to be minus 3. Now a and b are already known, so the equation of the line now can be determined. So the oblique asymptote, as I said earlier, was determined by ax plus b, but we obtained a to be 2 and b to be minus 3, so it will be 2x minus 3. So this is, you see students, the asymptote that we have. So as you are moving far away from the x-axis, from the y-axis, our function gets closer to this inclined line, this, you see, increasing line, because we are having positive slope. Now coming to the horizontal asymptote, whenever we have, students, the oblique asymptote, you don't need to expect the horizontal asymptote because the degrees are not identical. The degree of the denominator, the numerator is greater than the degree of the denominator. If this is so, you don't need to expect, okay? You don't need to expect this horizontal asymptote. So no horizontal asymptotes because the degree of the numerator is greater. So what we need to do is we have to look for the vertical asymptotes, and for that we have to try to find the case where the denominator is going to be 0, and that is not attained. As you see, this is x squared plus 1, and this can't be 0 because of this. We don't have any vertical asymptotes, as can be shown. No value makes, you see, no value here. No value of a makes this limit to be either positive or negative infinity. So we don't have vertical asymptotes, and the oblique asymptote is already calculated, so it was wrongly written. So that is the idea we have. I hope you have understood everything. So now the oblique asymptote is already written. The horizontal asymptote is also specified there. So the vertical asymptote we don't have. I hope you have understood everything here. Thank you so much.